Okay, this is an extra video. We learned Venn diagrams this week. It's an extra video to show you how to use Venn diagrams to find greatest common factor and least common multiple. If I was to try to find the GCF and LCM of two numbers like 12 and 16, first I would make a factor tree for both, find the prime factorization of both numbers. For 12, I can start with any two factors. We'll use 4 and 3. Every time I find a prime factor, a factor that's a prime number, I circle it and stop there. The factors of 4 are 2 and 2, both prime, so circle them. And then for 16, I could use 4 times 4. Neither is prime, so I keep going. Factors of 4 are 2 times 2, circle those. And the factors of 4 are 2 times 2, so circle those. So we have the prime factorization or factor trees for 12 and 16. Then we look at which prime factors do these two numbers have in common. Well, they share a 2, so I cross off a 2 from both, and I put a 2 in the middle because they both share it. I'll designate one of these circles as the circle for the prime factors of 12, and the other circle as the circle for the prime factors of 16. There's another prime factor they share, another 2, so I cross off a 2 from both factor trees, and I also put that in the middle. Now they don't share any more prime factors. 12 still has a prime factor of 3, but 16 doesn't have a prime factor of 3, so I put that prime factor of 3 over here on my Venn diagram for 12. And I cross it off to keep track of what I've already used. I have 2 more prime factors for 16, 2 and 2, and they'll go here because they're not shared by 12. Now, an important step here is after you think you've placed your prime factors correctly, check it. This circle is 12, so I multiply all those prime factors together. 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12, so that circle checks out. Now I just focus on this other circle. When I multiply them together, my product should be 16. 2 times 2 is 4. 4 times 2 is 8, and 8 times 2 is 16, so both circles check out. Now the GCF will simply be the factors that are shared by both numbers multiplied together. So the GCF would be 2 times 2, or 4. The LCM, once I have all my prime factors placed correctly in my Venn diagram, will be all the prime factors multiplied together. So 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 more is 48. So LCM equals 48. So for 12 and 16, using this Venn diagram method, we found our GCF is 4, greatest common factor is 4, and LCM, least common multiple, is 48. Well, why would we want to know the greatest common factor and the least common multiple? Greatest common factor is used to simplify fractions. So if I had the fraction 12/16, I could simplify in one step if I knew that the greatest common factor was 4. I would divide both my numerator and my denominator by 4. And I would get 12 divided by 4 is 3, 16 divided by 4 is 4, 3/4 is the simplest form of the fraction 12/16. Why do we need the least common multiple? Least common multiple is usually used for adding or subtracting fractions. So if I had, for example, fractions with the denominators of 12 and 16, like 7/12 plus 3/16, if I know my least common multiple is 48, I know that's the lowest common denominator that I want to use for both these fractions. So I would find the equivalent fraction using that least common multiple or lowest common denominator. So I'm going to need to multiply by 4 to get 48 here. 7 times 4 is 28, 12 times 4 is 48. And to turn 3/16 into 48ths, we need a factor of 3 over 3. 3 times 3 is 9, 16 times 3 is 48. Now I can add those fractions using the equivalent fractions. 28 48ths plus 9 48ths would equal, denominator stays the same, we just add the numerators. 28 plus 9 is 37. So 7/12 plus 3/16 equals 37 48ths using the least common multiple or lowest common denominator. So that's why you want to use GCF and LCM, and that's a good way to find them. That's it for this video. I'm going to show you with 3 numbers on the next video.